So everybody, I want to thank Paul Barton, PSB Speakers, for joining us tonight. This one was fortunate enough that we just started making connection about a week and a half ago. And my usual 5 questions tonight's going to turn into like 8, because I've been following Paul and PSB since I was a kid and all that. Sadly, I tried to clone his flagship speakers with a pair of Paradigm speakers, and it was finished college, and you know, Paul knows the whole story, and I think everybody here's seen the pictures anyways. So I'll get started with the questions, because there's a few of them. And so the first question I got for Paul tonight is, you first started building speakers in high school, as did a lot of us here in the club. From that first experience, please explain how you took that passion, expanded it with your education at the University of Waterloo, and who was the employer that you co-op with? And you might want to explain the co-op to these guys.
Okay, well, I'll take you back to my high school days. And what I can maybe do is, if you want to share the screen, I can give you a little bit of background to me.
Of course. There. Yep. There we go.
So there I am before bed when I was 7 years old, well, maybe 6 years old, 6 or 7. And that's really the background to how I got into speakers, was because I have a strong musical background. When I was 11 years old, my father built me a full-size violin, and you can see in this picture, just to the right top of the corner, you'll see the mold that a violin gets built around. And then it's clamped, and the sides are all clamped, and the back is put on, the sides are built, and then it's taken out of the mold, or the mold is taken out, and then the top is put on it. Of course, you have to put on the scroll. And this is the bench that he built the violin on. You can see in the back here all the chisels and things that he used. And this was a violin that my father built based on a very famous Stradivarius violin called the Messiah. And it's the only violin that Stradivarius built personally that has never been played by a human being. And it's under glass in England somewhere, and it's been highly documented. And so my father got the plans, which was well published, and he basically cloned the most famous Stradivarius violin. And that's the violin I'm playing at 11 years old. He built that violin in 1963. I still have it.
Nice, nice.
And so the next slide was at the very beginning, when we had our shop up in St. Jacobs. And just before we opened up the shop in St. Jacobs, I used to work in a hi-fi store when I was in high school. And the hi-fi store was near the University of Waterloo, part of my hometown. I lived in Kitchener-Waterloo, Ontario, Canada. And the university students, when they got their student loans every year, would come into the hi-fi store to buy their hi-fi system for their dorms. And I got quite a following who would come in, and they would buy kits that I would build in my dad's shop, where I would build the crossovers, put all the drivers together in a box, cut the panels, drill all the holes, make up the wire harnesses. And all the student needed was a screwdriver and a soldering iron. He could build the speaker in his dorm. So that's really, and I used to put the PSB logo on those products, even before PSB as a company was started. And when I finished high school, 2 high school buddies of mine, the summer of '72, we set up shop in St. Jacobs and started building loudspeakers. And when September came around, I joined the University of Waterloo. I was a co-op student. So you work for 4 months, and then you go to school for 4 months, then you work for 4 months, and you alternate through your university career. So I was actually employing myself on my work terms. And it was kind of neat because at the end of work terms, the university would send the president of the company a questionnaire to see how the student was doing. So my guidance counselor and I used to get a real kick out of that because I was able to fill out my own evaluations. And then this is more present day. This is the laboratory at the National Research Council. You can see all the associated equipment. So this is where all the crossover networks are built. And actually, there's an old system there for doing measurements. This system here, which was the original measurement system back in the 80s. And actually, it still runs in DOS and it still works, believe it or not. So that computer there is 30 years old.
Is that signal generator a Keithley? The one just behind you to your left there? Yeah.
Up there? No, that's an Amber. It's
Okay.
made by a company out of Montreal years ago.
Oh, wow.
It's very similar to an Audio Precision distortion amp. And there's an Audio Precision up over here.
Okay.
And then in the Anechoic Chamber, which you'll see pictures of later, there are 5 microphones. So this is the mic preamp, but there's a multiplexer which all 5 microphones are plugged into, and it has a scanner on it. And I can actually, and the microphones in the chamber are placed at 0 degrees, 15 up, 15 down, 15 left, and 15 right. And what I like to do is I like to do measurements in what we call the listening window, which is the 15-degree up and down and 0. And the reason I like doing measurements like that is when a tweeter, for example, on the baffle, you get a phenomena that occurs, some people call it diffraction, where the energy of the tweeter, say it moves out on a half cycle, that pressure moves across the baffle at the speed of sound in air. When it reaches an abrupt change in the surface, that actually generates another signal, which is some people call diffraction. And that signal then arrives at some point in time at your ears. And there is a point where it can be out of phase or in phase. So you get destructive and constructive interference because of this phenomena that's happening at the edge of the cabinet. Those kinds of phenomena I'm not that interested in because I can't do anything about that. And if you move your head or the microphone any amount, that frequency changes because of the path length difference and the time difference between the source and the diffraction. So diffraction creates bumps in the frequency response, but so do resonances. So if there's a resonance, it's everywhere around the speaker, whereas diffraction at one peak or dip only occurs at one point. And if you average in 15-degree windows, you can separate the resonances that are everywhere from diffraction, which is very space or very position sensitive. And they tend to average themselves out because they're simply constructive and destructive interference that are frequency related. So the whole setup is quite efficient in determining things like resonances versus diffraction on a loudspeaker, and making judgments in the crossovers and treating the diaphragms to get rid of things. I want to know that it's a resonance and not a diffraction. So those are the early day pictures. Getting back to your question, I guess I kind of answered the question already.
Yeah, no, that was the whole thing. You led in from question 1 into question 2, which was perfect.
Oh, what is question 2 now?
So no, I got it all here. So your work at the NRC, or National Research Council of Canada, is legendary and has been copied both here in the US and worldwide. And I'm referring more to your IEC room
Right.
with the 70s furniture inside, which again,
Right.
I wish I had the chance to get in there one day, but anyways. Can you talk about the work that you did in the early 70s with Dr. Toole and how that led into the company that bears you and your wife's name at present time?
Okay, I think what I can do is give you a few photos,
Okay.
and then I can also show you about a 2.5-minute video that really covers what you just asked.
Okay.
First, I'm going to show you. There are really two anechoic chambers that are available through NRC and the government. This is a picture of the largest one, and this chamber, the wedges are 2 meters deep. So you see the tips of all the wedges. Well, they go back, and you can see two people standing there, so you can see how deep those wedges are. And the floor that you see in there is actually what they call the 2-pi setup. In other words, they're all 5 walls are absorptive, and 1 wall is solid. That's what they call a half-sphere anechoic setup. If you take that floor out, which is removable, there is a set of wedges. There's a set of wedges. Can you see my screen still?
Yes. Yeah. Basically, we're both taking control now. You've got control, and so do I. I just got to get some people out of the waiting room and into the meeting.
Do I admit this person?
Yeah, please. And I think I should have that ability now too. Controls. Sorry about this, Paul. It's
No problem. I'm learning too.
fair enough.
I think as time goes on, more and more people are going to be using this for communication. So
Yeah.
any time spent here, I think, is well spent.
Thank you. All right, so we should have everybody in from the waiting room now, hopefully.
Okay, so that's the big chamber, and what I primarily did I haven't done much work in this lately, but what I primarily did was to do some subwoofer designs, because this chamber, without any correction, is pretty much flat down to 20 hertz. And I also used it to measure a speaker in this chamber, and then take that same loudspeaker and put it into the smaller chamber, which I'll be showing you. And if you put the speaker in the position where the reference calibration speaker was put, that was calibrated in this chamber, you can create a correction curve for any speaker that's put in that position in the chamber. So I can get pretty good data in the small chamber that was made possible by calibrating it to this larger chamber. Again, that's an older picture. You can see back in
chairs.
Well, not only the chairs, but the monitors are CRTs here.
Yeah.
And so you can see up in the top there, there's another screen that shows the video looking in the chamber at the speaker that's set up on the table here. So you can monitor, and I can also with this box, I can control the rotation of the table, and with, oops, did I lose?
Oh, that was me. Sorry, my apologies. Okay, we're back. That was me.
Okay, and then I don't know where the box is in this picture, but there's, right here, there's a box that allows me to move the 5 microphone array up and down. So it depends on the height of the speaker on the table. I can set the 0 microphone to be in the design acoustic center. I typically design speakers based on 36 to 39 inches off the table. So if it's a bookshelf, I add 24 inches to the bottom of the table, so that I put the microphone where the speaker would be on a 2-foot stand in a room. So I try and do all the acoustic voicing and look at where the lobing between multiple drive systems faces, so that the listener is either, when sitting and standing, is in the in-phase lobe between all the different drivers.
Right, that makes sense. And again, I think I asked you this question on the phone as well. The thing I like with a lot of your designs, even the latest and greatest, the little alphas up to your the old Stratus Golds, and even your Imagine T3s, is you always arrange the mid-range on the top and the tweeter on the bottom. And I know there was a whole method to the madness behind that, but I always seem to like that sound better than the other way around.
Well, I like to think of speakers as being a social activity. It not always is. It's sometimes a solitary activity, but listening to hi-fi is very often done with a group, or it's also done when some people are sitting and some people are standing or whatever. So I kind of know where the ears are going to be in a room. So I'd like to place the drivers such that the way they work at the crossover frequency, and I use often fourth order acoustic linguist filters. And if you look at the way the lobe tilts with a tweeter woofer combination on a typical fourth order linguist rally acoustic filter, the lobe always tilts in the direction of the woofer. So that's why I put, or the mid-range in some cases, that's why I put the mid-range above the tweeter, because the lobe, I voice it for seated position, and then the lobe tilts up so that there's no notch between the mid-range or woofer in a two-way system and the tweeter, so that from the seating to the standing position, the speaker's response is very similar. And you'll find a lot of speakers do sound different when you stand up. And it's because they haven't tuned it and have the lobe tilting in the direction up.
Right.
That's the reason why I started configuring my first system that way was when we were in Waterloo I designed that in 1979 was the first time I took that approach. Because when I was doing measurements, I realized, well, no, when you go down, it's the wrong way. So doing a little bit of fooling around, I realized that the lobe in the filter, I was using a fourth order back in those days,
yeah.
The lobe was tilting in the other direction. So I inverted the drivers and it worked.
Yeah. The proof's in the ears.
So somebody mentioned earlier the IEC listening room. This is it. The old 70s furniture.
Yeah.
And yeah, this room was in fact set up in the 70s, although it did get upgraded over time. In fact, when Floyd first started doing listening tests, he was actually doing listening tests in the other side of the room. The room was turned the other way, but there's a door on the far right-hand side of this picture. So the listening area was only from about 2/3 of the way in from the right wall to the left wall. And it couldn't do stereo. It was kind of awkward. So, and the reason they had to do that, I'll just give you a little bit of anecdotal story. Where the screen is there, that screen wasn't there, and there was a bed behind or in that back of the room. And what they used to do is they had speakers on the right wall at the end of the bed, and they would pay people to sleep in there. And then during the night, they would put all these probes on their brain. And during the night, they would play different sounds, and to see how the sleep modes in the brain were reacting to outside sounds, because they were trying to profile in the acoustics division environmental noise and how it affects people's sleep. And they did that experiment for many, many years. But when that experiment finished, Floyd was able to put all the screen and the setup at the other end of the room.
Nice.
And you can see here, there's a switcher, and then behind the screen, there's a light, and there are 4, 1, 2, 3, 4, and on the switcher here, there's 1, 2, 3, 4. And these tests are set up to be double blind screen listening tests. And what that means is the listeners, of course, don't know what's behind the screen, but neither does the person who's operating the source or the music. And very often they'll have listeners in there, and someone will very methodically switch between the loudspeakers. And then towards the end, the listeners will be given a chance, because they're going to be filling in all these score sheets. And then later on, they can actually pick up the remote and switch between the speakers to kind of review what they've already heard and listened to before they give their final scores. And of course, all the speakers are calibrated to be at the same volume with this microphone that's set up each time we set up a set of speakers. Something else that's kind of unique about this room is that you'll notice these panels on the side walls, and some of them you can't see, and some of them are actually, they're all resonators, and the whole back wall, you can see a little bit of it here, is actually a large membrane. And the purpose was not to make it different than a typical room, but this made it possible. And in any experiment, what you want to try and do is you want to try and make it so that there is only one variable. Of course, if you have 3 listeners in a room, each listener might hear a different sound depending on where they are in the room. So there was a real attempt by Floyd to create an area in the middle of the room where you see those 3 chairs. And if you do a frequency response of any of the 4 speakers across the front, in those chairs, the frequency response at low frequencies will be very close. And it was done by strategically placing and tuning these panels so that this listening area gave a very constant output. Now you might say, well, that's a compromise. Of course it's a compromise. The reason for doing it this way is for us to be able to do more than one listener at a time. And otherwise collecting data takes a very long time. If you can accelerate the data consumption or the data that you can acquire 3 times what you could by just simply trying to keep the low frequency activity or influence that the room has as neutral as possible in all 3 positions. And of course, during the test, we invite the listeners to, play musical chairs too, to try and even minimize more the effects of the position that the listener is in the room. Because we don't want the room to influence. Every speaker is going to sound and have the effects that a room has no matter where it is. So if you had 4 of the 4 speakers, you want to try and compare them equally. And the tests were done both in stereo and in mono.
Okay.
One interesting result was we had many speakers that were, well, in the early days, all the different brands were tested and listened to and compared to measurements to see if there was any correlation. And of course, we all know there was, or at least everyone who's bought into all this research realizes that, that there is no real personal taste in listening.
Right.
In fact, what I'll show you next is a little video that really talks a little bit more about the relationship between listening and measurements. This is another machine that is often used to do evaluations. It's what they call a laser vibrometer.
Mm-hmm.
And what that does is it can actually, scan the side of a speaker panel and tell me how the panel is moving at different frequencies. Really helpful in trying to determine with a real sample where the bracing in the cabinet should be placed. This is the outside of that building. It's kind of the building has morphed over the years. The Anechoic Chamber is actually in the back part of this building. This part of the chamber was originally what they called the ballroom, and actually it was the opposite of an anechoic chamber. It's a reverberant chamber where all the walls are solid and they're highly reflective. And so there's a lot of acoustical testing that can be done. In fact, you can measure the sound power with one measurement in this kind of an environment of a loudspeaker, because if you put the microphone far enough into the reverberant environment, you will actually be measuring the total energy that the speaker is putting out, not just the on-axis response. Now that particular part of the chamber or that setup has been changed to inside there is a extremely sophisticated, high-powered electron microscope. And it's almost half the height of this inside of this building. And it has actually they built a building inside the building. And this particular land is only about 5 feet above bedrock. Ottawa is a part of the Canadian Shield. Canadian Shield runs right through this area along the Ottawa River, which is just in behind here.
Right.
And so this is all bedrock. So they actually dug down to bedrock to put the microscope on. The little white building here is the building I showed you just before. There are buildings in all of the sciences. This is aerospace here. This is, they actually have a waterway inside here. It's a very long building. And they design the hulls of ships in there. They also, for a time, I don't know if they still have it there, they actually built a model of the St. Lawrence Seaway in order to study the locks and the control of the water flow in the St. Lawrence Seaway, all the Great Lakes and everything. They had a model of that inside this building that they used. Then there's actually some buildings that you don't see here, but there's about 65 buildings in all at the National Research Council, which employs about 1,000 PhDs in all of the sciences. That doesn't include the technicians and all the support staff. That's just a PR picture we did when I was developing the Imagine series. So I'm finished that little show, but I have a video that I think kind of covers a lot of this if you want to bear with me for, it's about a 5-minute video.
Yeah, we already checked all the technical stuff beforehand, so there we go. All yours, Paul.
That's the cesium clock for Canada. The wind tunnel.
Yeah. One of our club members, actually, it was John, has been up there. I think I mentioned to you on the phone call the other day, where he was where they did all the icing tests on the airplanes and stuff like that. He said it was really cool.
I'm about to talk here, so
I'm sorry.
I'll explain. That's building research where they test materials.
The main stimulus for creating the National Research Council was to help Canadian technology compete with technology around the world. And because of Canada's population and its partner, the United States, being the closest competition, the critical mass the US has was difficult to compete against unless Canada could form some kind of technological think tank.
I was much younger then.
Canadian industry compete worldwide. The National Research Council was started in 1916, and the purpose of NRC was to help Canadian industry and technology compete around the world. In Canada, they formed the National Research Council, which is basically a think tank employing about 1,000 PhDs in all of the sciences. And the main campus is where I am today, which houses about 65 buildings, going from chemistry to microstructural sciences, better known as physics, right through to biotechnology and aerospace. The biggest advantage that I believe NRC has to offer against other acoustical setups, even one that we might even consider building ourselves, is that not only are the physical resources at the National Research Council, but there is a strong history of research that's gone on here. Not to mention the fact that there are many people specialized in acoustics, psychoacoustics, which are a strong resource which can be utilized here at the National Research Council. So it's not just a physical laboratory, it's a whole resource that PSB and other Canadian technological companies can use to help improve their products. Just to point to one of the accomplishments that have been identified here in the acoustics division at the National Research, the strongest recognition, certainly in the consumer market, is all of the research that went on between 1974 roughly and 1984, which profiled much of the research which we apply today in loudspeakers. The results of those tests, which were correlating subjective evaluations, listening to loudspeakers against measuring loudspeakers in an anechoic chamber, just like this. Number one, keep in mind, these are blind screen listening tests. And by that, I mean, the listeners don't know what they're listening to, and they're just asked to make judgments and keep score. Number one, most of the people, most of the time, agree on the relative qualities of a group of loudspeakers. So if I put 4 speakers in a blind screen listening test behind the screen, get a group of people to listen and do scoring, I would find that they would all gravitate towards one speaker versus others. The second thing that we have learned is that musical experience and musical taste are no prerequisites for being a good judge of sound. What that means is that you don't have a tin ear. In fact, most people can hear good quality versus lesser quality. The third thing that we've learned is that a properly interpreted set of objective measurements, all the tests that we do in this chamber, which include frequency response, both in the on-axis, off-axis, and total sound power, distortions, all types, harmonic intermodulation, that those measurements, if done properly and interpreted properly, correlate directly with listener preferences. At the beginning of this research, we had to define what it is we were trying to achieve. And PSB has always and always will, for lack of a better way to describe it, designed loudspeakers which are true to nature. There's nothing added to what is in the music, and there is nothing taken away that was intended in the music. And that's what a speaker should be. It should be a window to what you see or hear, just like a glass is what you see through the window, without any tint or any colorations, which are sometimes spectacular, sometimes bigger than life, but they're not natural. And we like to think that our speakers are true to nature. And that is the goal. That is the objective for PSB.
Okay, there's more stuff, but maybe you should. That sort of covers all the NRC stuff.
Yeah, yeah.
Yeah. So, how do you want to proceed?
So this is the storytelling part where about how Mirage was created, tangent loudspeakers. So I'll start off with the question to set you up, and then I'll let you carry on, because this is really cool, this next part. So could you elaborate for us the work you did for tangent loudspeakers, how Mirage was created out of necessity? I'll let you elaborate.
Okay, well, I told you this story the other day, Joe.
Yes.
And when we were in St. Jacobs, which is a little small Mennonite town, in fact, when I used to go into the office in the mornings, coming from Kitchener, I would see more horse and buggy on the road than I would see cars. It was a really quaint little place. And, you know, as we got started in the late 70s, you know, things were really booming. There was the English invasion of loudspeakers into North America, companies like KEF, B&W, Harbeth, all of these companies. Celestian. So where was I? Yeah. So in the late 70s, you know, things were booming, and a company out of England, Tangent Loudspeakers, was one of these English invasion speakers. And it was distributed by a company in Canada out of Toronto called Inception Audio. And they were not only distributed in Canada, but it distributed into the United States. And they were doing quite well, but I think in the late 70s, a couple of years after Tangent really got going in the United States, for some unknown reason, Tangent went bankrupt in England. So obviously, Inception Audio's supplier of Tangent loudspeakers dried up overnight. And they were selling actually Tangent loudspeakers to a hi-fi store in Boston. Can't remember, it's a house. Can't remember the name of the store. But who worked there, who was partner for that was, was a partner for that was a guy named Kevin Vicks. And some people pronounce it Kevin Vaux, but I don't know if you know a brand called Revell out of Harmon. Well, Kevin is sort of the main guy when it comes to the Revell loudspeakers. But he worked in a hi-fi store in Boston back in the 70s and was a real fan of Tangent loudspeakers. And when Tangent dried up, he actually sold his shares of the store to his partner and moved to Canada to design replacement loudspeakers for the Tangent line. And I quoted on a contract to build those speakers for Inception Audio under the Tangent brand name. And we started doing that. Kevin designed 2 models. And, you know, we would build them from time to time. And every time we built them, Kevin would drive to St. Jacobs and be on the line when we were producing them to check them for frequency response and do all the QC and stuff. He wanted to be there. And then a few months or maybe half a year into the activity of building speakers for Tangent, I got a knock on my door, and it was John Greenbanks, the original owner of Tangent. I don't know how he found out where we were building his branded speakers, but he wanted us to cease and desist using the name on products we were building. And I simply told him, you know, we're a contract. I think he knew it, but we were a contract dealer or a contractor for building the loudspeakers. And the next thing I know, when we were when we were running Tangent, we started building a run we usually started in the morning, and then Kevin would come around lunchtime and be up on the line just watching the QC. So we started building Tangent in the morning, and Kevin came to the office around noon with new stickers to put on the cartons, new owner's manuals, and new logos to stick on the product. So in the morning, we were building Tangent loudspeakers, and in the afternoon, we were building Mirage loudspeakers. So that's how Mirage was born. And then a few years later, Howard Heiber, who owned a company called Global, which eventually became API, he outbid me and started doing the contract of the Tangent, or of the now Mirage loudspeakers at another company in Toronto called API. They were just a cabinet maker that, you know, was building sort of an OEM supplier of cabinets in the Toronto area. Eventually, when 82 came around, it was really difficult for the dealers, and so Inception Audio wasn't collecting enough money from their dealers, and they owed their supplier enough money that he acquired the company under those circumstances. So that's how API acquired Mirage. Same kind of thing happened with Energy loudspeakers. Energy was having their products built at this cabinet company, which was owned by Howard Heiber. And he acquired that brand as well. So that's how API got started, Audio Products International. anyway, that's just a little bit of an anecdotal story about the Canadian audio industry. There's a lot of other affiliations. I mean, I knew two of the owners of Paradigm. That they actually worked at PSB before they started Paradigm, and so PSB was kind of a sort of a seed company for a lot of the activities that ended up happening in the loudspeaker industry, in conjunction with, and to my good fortune, that Floyd Toole, who was a scientist, worked for the National Research Council, had a real interest in sound reproduction. By the way, I invite you all to purchase his book, which is available on Amazon. It's called Sound Reproduction, and it's a very, very informative book, which covers a lot of the things that I experienced firsthand when I was attending and doing product, and still do product development at NRC. Just a little sidebar there, NRC is literally closed down, so I'm having difficulty figuring out how I'm going to continue doing some product development. I just got a letter from the management at NRC in Ottawa saying that if I make a good case, they'll figure out a way to get me in there. So I think that kind of answers that anecdotal question you made. What's next? Oh, I talked about the English invasion, Paradigm Energy. Oh, I should maybe mention a little bit about activities that took place at NRC. This was before Dr. Floyd Toole moved to the Harman as the head of engineering for Harman in 1991. In 1987, we formed a company called CARC, the Canadian Audio Research Consortium. And it was in conjunction with the National Research Council, Paradigm, API, which was Energy Mirage, a high-powered studio monitor manufacturer out of Ottawa called SOTA. They built and designed all the studio monitors, high-powered studio monitors for the CBC in Canada, which is the equivalent of the BBC in England. And PSB, and the four companies formed this company called CARC, and we started a research program called Athena. And the intent for Athena was to design the protocols or the technique of designing a loudspeaker that could adapt to the room. I mean, we all recognize back in those days the room was a real problem. A real problem, and something that, basically as a designer of a loudspeaker, I don't have much control over. So we wanted to see what could be done. And of course, when you try and make a speaker smart in a room, part of what you're doing a lot of what you're doing is the equalization of the loudspeaker to get rid of some of the room effects, the standing waves, things like that. And how we did this is that we set up a special room. In fact, the room, it wasn't the listening room I showed you. That there's another room beside it, which I don't have a picture of, that actually was what we called a variable room. We could change the room from a square to a rectangle to an L-shaped room. So we could try all kinds of different room configurations by changing the walls. The walls in this room would move around and could be clamped in different places. And we used that room with listeners to get them to tell us when they thought a speaker that was EQ'd in the room sounded the best. And that's how we kind of developed what we thought, and what I still believe is the target curve for a room correction. Something we currently use and have I implemented in all of the NAD AV receivers that have Dirac room correction. The target curve that's in the Dirac room correction for NAD is in fact derived from this research. And going even further, the room feel that if any of you know, we do headphones as well. The room feel trademark that we incorporate into the headphones is in fact based on the research that was done to set what the target curve correction for a speaker in a room. You have to keep in mind that a direct radiating loudspeaker radiates all of its low frequency energy in 360 degrees. And as the frequencies get higher, the radiation becomes narrower and narrower on the front. And typically, when we listen to any brand of loudspeakers, they're designed to be flat on axis. But when you put them in the room, a term a lot of people use is room gain. But there's also some attenuation that occurs at high frequencies. And the reason for it is part of the energy that you hear comes directly from the loudspeaker in a room, but also part of the energy is the early reflections off the floor, the sidewalls, the ceilings. And then some of the energy is the reverberant energy, which is the sounds that rattle around the room until they get to you because they're not at a distinct angle. And if you take a typical loudspeaker in a room that's flat in the anechoic chamber and you do averaging of the energy that the speaker is putting into the room, you will see a response that's somewhere similar or somewhat in between the on-axis response and the sound power that the speaker has, the total energy the speaker is putting up. And we in a room hear a lot of the combination of that. So when you put a pair of headphones on, you want to have something similar to that. That's why we incorporated that target curve or a version of that target curve in the headphones. And it would take me many of these seminars to kind of go deep into all of the things that are involved in that. But I just wanted to touch a little bit on the whole approach, not only to room correction, but also to the effects. Keep in mind that when you're listening to music on headphones, you're listening to music that was recorded to be played back on speakers in a room. So the recording doesn't have the effects that the room has in it. So you need to add that to headphones when you voice them. And there's been good evidence. In fact, Floyd and his group at Harman did, Sean Olive, who works in the research part of Harman, used to work at NRC and moved along just shortly after Floyd moved to Harman. And he does a lot of research and wrote about 5 papers on the subject of headphones and responses, and pretty much came up with the same conclusions, which doesn't surprise me at all. We sort of all came from the same camp, if you know what I mean. What else did I have here? So that explains the association and the research that was done at NRC. And I just sort of elaborated a bit by saying how some of that research actually migrated itself into many years later when I decided to design headphones. So I've been able to use some of that knowledge to incorporate in what I think is the proper listening experience when you listen to music that was recorded to be played back on speakers on a pair of headphones. I got a few questions prior to this as well from some members, but let me see if I can see where the chat.
So for example, Pete texted me a question for you, and I posted it into the chat, but I can read it for you real quick here. Pete says that he has a pair of PSB Stratus Gold Minis, and he wants to know what PSB's latest speaker series is, and how does it compare to the Stratus Gold Minis?
Well, the right name for it is the Stratus Mini. There was a model called the Stratus Gold, and then there was a model called the Stratus Mini. same industrial design, but the Mini was a 5.25-inch two-way, 6.5-inch two-way, and it used a 3/4-inch metal dome tweeter. And the equivalent of that product today is the we call it the Imagine B. Is that the question? Is that the question that was asked?
Yeah, he just wanted to know what compared to that speaker that he had. So the Imagine B is the equivalent.
Well, it's the same it's the same basic platform. It uses different drivers and it's a different shaped cabinet, but it's around the same price range and it's about the same size. It's in a highly finished, very organic shape, and I'm not hesitant to say that there's things that I could tell you that I maybe shouldn't tell you, but I will give you a hint that I am currently upgrading a lot of that product category in the PSB line. So hang on to your hat.
Okay, so things are in the works.
Pretty close to being finished, actually. I just got a call just an hour ago on some topics that really are going to push this project into full speed ahead. So yeah, there's some work going on. I'm also going to show at some point in this presentation a little bit of information about a new product category that we're getting into in PSB. Well, not brand new, but it's an area that more and more speaker companies are getting into, and that is some more sophisticated DSP controlled powered loudspeakers. So I'm going to show you a little bit about what's about to come out in the next 60 days.
I have another question this is from Jeff, and he's asking if you believe in speaker coatings, and then he explicitly mentions graphene.
In speaker cones?
Coatings. I'm imagining he means on the cones, yeah. Like graphene coated cones, which I think is some kind of microstructure of carbon.
Yeah, it's a two-dimensional layer of carbon. Graphene is an amazing material. I've seen that, I think Ciaz put a layer of graphene on their magnesium cone now. And the big advantage of graphene is that it's even stronger. It's up in the same strength as diamond, or even stronger. And so it makes for a very structural. And what it means is something that's stiff means that it's very difficult for it to bend. And that means bending is the same thing as stretching something. And a single layer of graphene on a substrate, or even graphene in multi-layers, creates a structure that is impossible to stretch. And if it's impossible to stretch, then you can't bend it, which means it's very stiff. So it has some properties that are kind of interesting. And I've experimented with these materials. There are many good materials for doing cones. Some take a brute force in making things really stiff, things like carbon fiber or even graphene. No one's really been able to create a graphene material that, well, there is a company in Montreal called Aura, and they have developed a vapor deposit technique of doing graphene. And it's something that I'm exploring as well. I'm very much into materials and experimenting with materials, and some of the new products that I just mentioned have some new and interesting materials that you will see. I hope
Thank you for that detailed explanation. I had a question actually, because I noticed you're using ceramic cones on a lot of your products, and
Well,
Like, is it-
I don't use ceramic. What I do there is there's a um, we use a ceramic filler that's embedded into polypropylene. So it adds a bit of stiffness to the softness of the polypropylene. So it's really adjusting the Young's modulus to be as ideal as it can be with the right amount of damping, but the right amount of stiffness as well. So we put ceramic flex into the material. It's not made of solid ceramic. It's polypropylene with a ceramic clay kind of compound that goes in it. That's what makes them their color. They're kind of a yellowish color.
That's a benefit. They look cool too, and they sound good.
Yeah. Well, yeah. It's not, as I always say, it's easy to build a loudspeaker, but it's really hard to build a good one.
It's true. Very true. Very true.
Yeah. Like, all you need is a woofer, a tweeter, and some wire, and you can make sound. But really hard to make a good one.
Well, when we were at the Dan Agostino thing last year, he said the same exact thing. Some guy goes to Parts Express, buys a kit, puts it together, and now he's a speaker manufacturer.
Yeah. Actually, the kits today are actually pretty good. When I was young, the kits were, they were terrible. All
right, let's carry on here. There's a few questions I know I vetted to you earlier. There was the one about the crossovers and all that, but I just wanted to carry on with the storytelling here because there's some more cool stuff that you wanted to go over. So go ahead.
I now found the window that has all the questions on it.
Oh, cool. Okay. Yeah. If you're comfortable, you can go ahead with those if you want. Pick the ones you want to answer. You don't have to answer every single one.
There's a question here that goes back to what I said earlier. I'll answer it real quick. Yeah. It says here, does the lobing effect that I mentioned earlier on the design, when you have a tweeter between two mid-range drivers, that they call a dapalito, which is just a way of controlling the directivity so that you have very little energy going way up and bouncing off the ceiling, and less energy bouncing off the floor. So it narrows the vertical dispersion and focuses the area. Whether the lobing will be a little bit unsymmetrical unless you're right in the middle and the tweeter is at ear level, then you would have symmetry up and down. But yes, the lobing on a dapalito will give you quite good consistency from the seated to the standing position. Let me just check another question here.
Yeah, no, go ahead. I purposely turned off the chat room because it just drives me nuts, so I let the guests deal with it. That way you can filter it out.
Okay, there's a guy fellow that Jeff Kalina.
Yep.
He sent me some questions.
Did you want me to pull those up or?
Okay, no, I got it here.
Oh, you got them? Okay, cool. I know he wants to.
Oh yeah, here it is.
There we go.
Well, the first question that Jeff asked was, he says, I'm intrigued by your integration of knowledge you incorporated from the association with Dr. Floyd Toole. Can you explain how that has impacted your design? Well, going through all those little videos and things that I showed you, it's pretty clear that all of the research that was done at NRC was really my education when it came to understanding what I needed to learn. I don't think, I think I'm very fortunate that I had the opportunity, because I was kind of learning what couldn't be learned in university very, very specifically. And I was able to start learning that long before the university was over. So it was a real benefit to be able to get a hands-on. And it really, in university, you kind of learn everything a little bit, but you don't focus. And I was, while I was doing that, I could really focus on what I really enjoyed doing and what I really wanted to do. And it just so happened Floyd's research was directly pointed at the questions and answers that I needed. Second question he sent was, I applaud you for the discipline required to have a product line priced so rationally. How have you avoided the temptation to develop very expensive products? I guess we're talking about, you know, Wilson speakers. Is that what we're?
Yeah.
Well, as in the early stages, we made what, you know, as a young company, we tried to do all the things right, and we made up a company goal statement. And of course, you have to stick to the statement when you're doing day-to-day business. And if you're not sticking to the statement during day-to-day business, you have one of two things to do. You stop doing it because it's not in your goal statement, or you change your goal statement. And our goal statement was to design, manufacture, and distribute a line of high quality, competitively priced world-class loudspeakers. So value was a big part of what we were doing. I really get a kick out of being able to produce something. It was fun in the early days at NRC because speakers were so different from one another. Brands had their own distinct personalities, and it was just wildly different between one brand and another. You had what they called the East Coast sound, the West Coast sound. There is no East Coast sound, West Coast sound. It's the sound reproduction. It's not, the speaker is not a filter. It's a window through which you see the acoustical event. And you know, so we, you know, in the very early days, I realized that, you know, NRC and the benefits of doing that. And we would put speakers in a listening test. And I used to, I'll tell you a little story.
Yeah, go for it.
I won't say any names because it might be embarrassing. But I had submitted a speaker that I had developed at NRC. This was in the mid 70s. No, this was maybe in the early 80s. I had a speaker which was it was a two-way system, sort of it wasn't a bookshelf. It was, back in those days, you put speakers on about a 10-inch stand, and they sit nicely on short stands. And I had a passive subwoofer, and a magazine through our PR people wanted me to submit for review. So I submitted it for review, and about I don't know, a month later, I get an email or a call. It was back in the 80s, so it wouldn't get an email. I got a call, and the person that was reviewing it, he was a freelance reviewer for a main magazine, and so he contacted me, and then he sent me a fax, because back in those days, that's how you sent sheets. He sent me a fax, and he was using an Apple computer, and he had some program in there that was doing some kind of frequency response, and I couldn't make any sense of it. And in the call he made to me, he says, you know, I was a little disappointed in the way this sounded, and basically here's the data that I accumulated, and I don't think I would really be interested in continuing the review on this, because he didn't want to have to publish a bad review for me. And I said, well, tell you what, why don't you and your editor join me in Ottawa, and I'll pay for your travel and your accommodations, and come on up to Ottawa, and we'll show you where we develop it, and I'll put you in a blind screen listening test, and you can experience the whole thing. And him and the editor were just anxious to come up, so they come to Ottawa, and we put them into a listening test, and it was kind of interesting to see the body language. Up until that point, they didn't realize that when they sit in that room and they can't see what they're listening to, and this is an environment, I mean, the NRC is quite overwhelming when it comes to how professional and how amazing the place is. They walk into this facility and they get into the room and they realize, holy crap, we're not only going to be evaluating speakers, they're going to be evaluating us, because we've done so many listening tests. We know what the results of the speakers behind the screen are. Now the listeners are under test.
Yeah,
we can tell whether you guys are good listeners or not, and they realize that when they get in the room. So it became a fairly nerve-wracking thing, because they'd never been in an experience where they don't know what it is they're listening to. So we put them through 2 rounds of tests. We usually do 20-minute tests, one in the morning and then one in the afternoon with breaks. And so we did a test in the morning. They came out of the room and they were panicking. And I said to them, well, if you're not really hearing really big differences, it's because you need to have some more time in the room to really adapt. Because when anybody goes into a new room and tries to do speaker evaluations or listening evaluations, it takes time for the brain to actually get rid of the room, and you can start hearing the differences. And there was strong evidence of that happening when we were doing listening tests, because the first round was usually all over the map. And then you do second and third rounds. We usually do 4 rounds a day, 2 in the morning and 2 in the afternoon. And by the second round, the third round, and the fourth round, all the data was, so it clearly showed that there was an adaptation, there was some adaptation required after a period of time in the room. And that's a real thing. We eventually start to hear the differences between the sources, and we can hear through the profound changes that the room can have. And thank God we can do that. So we went through the round of tests, and one of the speakers that we had behind the screen, of course, one of them was the PSB. I can't remember. One was an anchor we use all the time in the test. It was actually an Altec gold ring loudspeaker from way back in the 70s. They used it in recording studios. And then we had if any of you go back that far, it was a Snell, I forget the model number, but it was about the size of a refrigerator, a big Snell loudspeaker. And it was the current, highest acclaimed product in this magazine. And we just happened to have one at NRC at the time. So I put that speaker behind the screen because I knew that they knew that speaker. Yeah. And we did two rounds of double blind screen tests. They were only there for a day, and I wanted to spend some time with them in the chamber. So we did 2 rounds of tests. And in both rounds, actually, they picked the PSB over the Snell. And the PSB at retail was about $400 a pair. And the Snell was about $8,000 a pair back in mid or early 80s. So that speaker would be like $30,000 today. So it really showed them, and they kind of left with the tail between their legs. And I never did continue and submit the review for that particular model. But models after that, they took me a lot more seriously.
Oh man, it was a Type A. John Harville, who's the one who's got the funky crossover question. It was a Snell A.
Yeah,
Model A.
Yeah, the big Snell A. That's right. was about the size of a refrigerator. The third question that Jeff sent was, I would love to include your stand mount model in our upcoming Speaker 2 Fest event. May I follow up with details of the event? I guess that's a personal question.
Oh, no, because of all this COVID stuff and everything, all of our face-to-face personal events have been kind of put on the shelf right now. But Jeff organizes the Speaker Fest where he gets manufacturers to send stuff down to us. We rent out a convention hall in downtown Phoenix, have all these rooms set up and all this stuff. Last year we had Sean Casey from Zoo came down. We had all kinds of, we had the Tectons down there. So we're trying to add PSB to the mix now. And I think we have this, there's a dealer down here that does distribution for you guys. I don't know if it's Acoustic Designs or it might be one of the others. So that's where he's going with that
Okay,
question.
well, I'd be happy to help out if that's possible. I want to go back. I think one of the questions you had.
Yeah. Let's go back to my list here. So here we go. So Lenbrook, we spoke about a little bit where you've got your fingerprint or your acoustical fingerprint between the headphones and the D-Rack. So that was question 5. I think the next part is what you were leading up to was the smart loudspeakers.
Right.
Let me touch a bit on those. Take your time. Take your time.
Let me just show you. It's sort of a preview because these speakers are about to come out. And for those of you who know PSB, we just introduced last year or a little over a year ago a replacement and upgrade for the new Alpha series, which is we call the P5 and the P3. Well, I've done a powered version of both those models.
Nice.
And I'm going to show you that. Before I do, I'm going to show you one other thing.
Yeah.
Talk about powered loudspeakers, and I think, Joe, you and I spoke about it, and I think I mentioned to you that in 1973, I designed an active loudspeaker that we called, and we built it for till about 1980. So we built it for 7 or 8 years. And it was called the Beta 2. Mm-hmm. So if I can share the screen.
Yeah, Paul's got control, but I think he can just.
I think I set it up so that Paul, you should be able to just click share your screen down the bottom.
I got it. Yeah, I got it.
And,
cool.
And it should share it. Does it work?
Yeah. So
yeah, I see it. Yeah.
This is the back panel of the speaker. I took this picture today because I have one of the original ones in my storage area. So I went down and dug it out and just took a couple of camera pictures of it.
That's awesome.
You can see the serial number is 5419. I'm not sure, but it was just put on with an ink pad back in those days. And you can see the address is in St. Jacobs, Ontario, Canada. And what this was a servo feedback speaker. So there was an accelerometer on the cone of the speaker. And you fed the amplifier preamp output through a special cable we supplied, which had a DIN connector on one end and 2 RCA connectors on the other end. So you come from your preamp output, and instead of going from your preamp output back into your power amp, you would feed from your preamp through this special cable, and it would go into this speaker, and then the output of this line output of this speaker would feed the power amp. And the preamp signal was compared with the signal coming back from the woofer, the accelerometer on the woofer. And I was able to put enough negative feedback in the circuit to put about 30 dB of gain in the feedback, which allowed the frequency response to be adjusted and calibrated based on the feedback. And it also reduced distortion by about 30 dB. So the 2 controls you see on the back of this speaker, one, because each amplifier has different amounts of gain, I wanted to control the amount of feedback that was compared with the preamp signal so that it would always do the right correction. And different amplifiers have different gains, different amount of gain, voltage gain. And I created an 11 position switch, which in the manual I had a little chart that tells you how to measure the voltage gain of your amplifier and then set the right setting for the voltage gain to give the proper amount of feedback. And then there was a listening level. Because this speaker could go down so low, it was pretty much flat to 20 hertz. You could adjust a low pass filter, because if you really wanted to play it loud, you might have to trade off some low frequency capability, because it was only an 8-inch woofer. It couldn't produce a lot of output. This is the front of the loudspeaker, and you can see there, that's the original PSB logo, which was a P, S, and B stacked on each other.
Oh, okay. Yeah, I see it.
I designed that logo in a grade 11 geography class. I used Letraset Data 70 typeset to do that. And you emboss it onto a, like, this was routed on a pin router, actually. We used to use small bits and pin routers to cut these panels out with. And so all those carvings in there were done by hand. And that's a solid piece of walnut at the bottom. And I didn't bother taking the grill off, because back in those days, grills were not removable.
Yeah.
They were permanent, because we didn't put all kinds of pretty gaskets and trim rings all around the drivers. We just covered it up with a grill. Keep in mind, this was back in 1973. How old were you guys then?
4. I was 4. But
okay.
Oh, what did those speakers that you just shared with us, what did they retail for in 1973?
The one I just had on the screen?
Yeah.
Whoops.
Yeah, no, that's the one he's asking about. Yeah.
The Beta 2 was, that speaker, they retailed for $475 a pair. And that was expensive in those days. That was like that was back up in the price range of the AR3A and the larger Advent, not the larger, the powered Advent speaker back in those days. So it was competing with the Advents and the rectilinears and the time windows and all of those speakers back in those days, which were all around the same price. Yeah.
So you mentioned with the accelerometer on the woofer and all that. So, and I'm gonna do my damnedest not to hijack the conversation here. So back when Genesis loudspeakers had their money troubles and then they got bought by API, did you have any crossings with Arnie Nudell at that time? Or did you cross paths with him?
I didn't know Arnie Nudell, but I did know the engineer. What's his name?
Paul No,
he was one of the original engineers of a company called EPI.
Okay.
Out of the Boston area. Forget his name.
I know the loudspeakers. I can't remember.
But he was actually the engineer who did design those systems with the green foam surrounds.
Mm-hmm.
The Genesis.
Yes.
Yeah.
Cool. Sorry. Keep going. I didn't mean to hijack that.
Okay, I wanted to show you. So these are the new alpha powered monitors, and all the electronics are in the left channel, and you connect the left to the right. And so you have volume control and input selector by pushing the volume control in. There's an IR for the remote control. And it's kind of cool because it has 1, 2, 3, 4 different inputs. Sorry, 5. 1, 2, 3, 4. I'm sorry, 4 different inputs.
Yeah, yeah.
And so you can, it has an NAD RIAA phono preamp built into it. It has auxiliary analog in, has optical in, it has USB audio in, and of course it has Bluetooth in. So you have 5 inputs on a little speaker, and for young people, this is a complete system. The remote control also allows you to select different listening modes. There's just the normal flat mode. There's a spatializer mode. There's a spatializer with dialogue enhancement, and there's also just dialogue enhancement. So you can select between 4 different configurations. And there's also some tone controls on the remote control. And it uses, it does aptX Bluetooth.
Yeah, yeah, yeah. So 9624. Yeah. So those are the those are the KEF LS50 killers. There we go. We'll call them that.
Yeah, the price is quite a bit less expensive though. These are going to be $499. Well, the AM3, well, let me just show you the next slide.
Yeah, go for it.
So the AM3 is $349 a pair. That's the small one, and that uses a 4.5 inch and a 3/4 inch metal dome, aluminum, black anodized aluminum dome. And then the AM5 uses a 5.25 inch 50-watt amplifier. The amplifiers are actually the same, basically. The power supply is different between the two to give the AM5 a little more power. Yeah, so these will be available. These will be available in the next 60 days. And I'm having fun with these. They really sound great.
Cool.
And of course, it has a subwoofer output as well. It also has a USB power type A jack, which allows you, we sell a dongle, which is a wireless dongle. So you could actually connect the subwoofer output to the dongle, and the dongle would transmit the Wi-Fi through Wi-Fi would transmit to your subwoofer. And of course, these 2 controls on the bottom are to go to the other speaker.
Yep.
There's also a ground terminal for the turntable, because turntables need good grounding.
This is like the perfect starter because it's got everything there, and then it's kind of like the PSB gateway drug, you could almost call it, because everything is there: the amp, the inputs, and turntable.
Yeah, and there's a lot of DSP inside this. This thing, this speaker is from about 50 hertz. It really has a little bit of a rise and then it rolls off. It's down about 10 dB at just below 40 hertz. And that's pretty much the same for both of them. And above that, the speaker on axis is about plus or minus 3/4 of a dB.
Wow.